Welcome to Saucy Math. Today we're going to talk about inequalities and intervals, which are basically ways of describing sets or groups of numbers. All right, so I'm just going to jump right in and do some examples. There's really three different ways that these sets of numbers could be represented. So I'll just kind of show you how to translate between the different notations that we have and what they mean, and then I'll try to explain why we have three different ways to represent this, which you're probably not going to like the reason why. So for the first example we have here, we have what we call interval notation, which is parentheses, -2, 5, and then a closed parentheses. All right, so what this interval notation is telling us basically is we're looking at all the numbers starting from -2 and going up to 5. Right? And not just -2, -1, 0, 1, 2, 3, 4, 5, but all the numbers in between, all the fraction numbers and decimals in between those. All right, so every number in between -2 and 5. But the parentheses around our numbers here, they mean something as well. Right? So the parentheses next to the -2 means that the -2 is actually not included in the interval. Right, so it means we can use numbers like -1.9, -1.99, -1.99999. We can get numbers really, really close to -2, but not actually -2 itself. Right, and the parenthesis next to the 5 on the right side means the same thing. Right, our numbers can get really close to the number 5, but this parenthesis here means that the 5 is not included. So we can do numbers up to like 4.99999, but never actually have 5 as part of our set of numbers. Right, so to translate this interval notation into the inequality notation is actually pretty simple. Right, the number on the left, -2, that's like the left side of our interval. So we start with that. -2. The number 5 is the right side of our interval. So I'm going to put the 5 over here, but leave some space in between them. Right, so our variable, which usually we use x as the variable when we're using these inequalities, is going to be the numbers between -2 and 5. So -2 is going to be less than x, and then x is going to be less than 5. All right, so basically this is saying x is going to be bigger than -2, but x is going to be smaller than 5. It's going to be the x can be any number in between -2 and 5. Right, and since we had the parentheses over here, which means those endpoints, the -2 and the 5, are not included, that means when I do my inequality here, I just use the less than symbol. I don't use the less than or equal to symbol. Right? Remember, if there's a little line underneath this, it means x is less than or equal to 5, but that would mean that 5 was included in our interval, which in this case it's not. Right? So basically what you need to know to translate from one to the other, the parentheses means you use just the less than symbol. Right? And now we can also represent this inequality or this interval on a number line. All right, using a graph. So, and it's, again, pretty basic. So -2 is our left side. Now, since -2 is not included in our inequality or in our interval, when I put -2 on the graph, I put an open circle at -2. Right, and don't worry about where it is on the graph, just put a circle somewhere on the left side and write -2 under it. You don't have to like put lines for 0, -1, -2 and all that. Just put it on there and put a circle. Right, and then 5, the right side of our inequality or our interval, also is not included. Right, x can only be less than 5, not equal to 5. So I put another open circle at 5, and then I just kind of darken in the line in between them. All right, so this graph here represents x cannot be -2 because it's an open circle that's not included, but then any number between -2 and 5, but not including 5. Right, so that's three different ways to represent the set of numbers between -2 and 5. All right, so why do we have three different ways to represent these? You know, inequality, which is something you probably have learned before, are perfectly fine to describe the numbers between -2 and 5. So why do we need this extra interval notation to tell us the same exact information? All right, and the reason why is because mathematicians are a little bit lazy. They want to write things as concisely as possible. They want to use as few symbols as they possibly can to, get their ideas across. And writing this with a parentheses here is a little bit less work than writing the inequality. Therefore, mathematicians prefer to use this more concise notation, which means now we have to learn all these extra rules in order to be able to do that. Right? So that's why we have all these extra notations, because mathematicians are kind of jerks sometimes. All right, so that's the first example, and all these other ones are going to be pretty similar with a few little differences here. All right, so the next one, we're starting with an inequality, right? 4 is less than or equal to x is less than or equal to 28. And you can go either way with this. You can take this inequality and change it to interval notation first, or you can change it to the number line graph first. Whichever way you want to do it doesn't really matter. I'll start by doing the interval notation. Now notice how this inequality is different from the one up here. Right, the one we did before was just less than symbols. The one down here, they're less than or equal to symbols, which means these endpoints, the 4 and the 28, are both included in our interval. So the symbol we use for interval notation when the endpoints are included is not the parentheses, but it's the square bracket. So it's square bracket 4, comma, and then our upper limit, or our upper number here is 28. And since 28 is also included because x could equal 28, we use the square bracket on the 28 as well. All right, so that's the difference between these two with the parentheses and the brackets. Parentheses means the endpoints are not included. The brackets means the endpoints are included, right? Which in the inequality means it's just less than, or if it is included, it's less than or equal to. And then when we do the number line graph, again, it's pretty simple to do that. Our left number is 4, and since 4 can be included, I put a filled in circle at 4. Our right number is 28, so I just move over to the right side, do a filled in circle at 28, and then just connect those two by darkening the line. All right, so square bracket translates to the equal to sign with the inequality, translates to the filled in circle on the graph. All right, the curved parentheses translate to the just less than sign in the inequality, translates to the open circle in the graph. And those things always go together like that. All right, so the next example here, we're given the graph, right? It's like we have -8 with a filled in circle above it going up to +1 with the open circle above it. All right, and we have to translate that into the interval and the inequality. All right, so to change that into the interval notation, again, it's pretty simple stuff. -8, that's the first number, that's the number that's furthest on the left, so I write that number down first. And -8 has the filled in circle, right? And like we saw up here, the filled in circle means that number is included. So in interval notation, if the number is included, we put the square bracket, right? That means we can use -8 as part of our numbers. All right, and then I put a comma, and my right-hand number is +1. So I write down the +1. Right, now +1 has an open circle here, which means that number is not included. So in interval notation, if the number is not included, we give it a curved parentheses. All right, so that would be our interval notation for the numbers starting at -8, including -8, and going all the way up to 1, but not including 1. And then if we want to write that as an inequality, again, the numbers are always going in the same order. So we start with -8 on the left. That number's included, right? It's a filled in circle, it's a square parenthesis, or so the square bracket. So it's less than or equal to x. But then the 1 on the right side is not included, right? It's a curved parenthesis, it's an open circle. So that's just x less than 1. All right, so -8 is included because it's less than or equal to -8. The 1 is not because x is just less than 1. All right, so you can see with the interval notation or the inequalities, both endpoints can be not included, both can be included, or you could have one included and one not included. And it can go either way. Like the next example, we'll see the same thing but kind of opposite. All right, this one, we start with interval notation. We have parentheses 0, 10, bracket. All right, so our left number is 0. So I start my inequality by putting down the 0. The 0 has the parentheses, which means it's not included. So I just put a less than symbol there. And then x. And then 10 is my right-hand number. And 10 has the bracket, which means 10 is included. So I do less than or equal to 10. All right, again, that square bracket means we can use the number 10, which means x over here can be equal to 10. And then when I go to the number line, I start with my left number. 0 is not included, so I make an open circle, write 0 underneath it. My right-hand number is 10, which is included, so I do a filled-in circle. Right? That filled-in circle means that we can use that number, and then I darken in the line between them. All right, and once you do a few of these, you start to get the hang of it. Once you get the translating, the brackets and the parentheses and what those mean, once you understand that, it's all pretty simple from there. All right, although the next one now is a little bit different, because now we have 3 less than x. We've only got a number on one side of the x in our inequality. Right, so 3 is less than x. Another way of writing that could be, if you switch it around, x is greater than 3. All right, so x are going to be the numbers bigger than 3. So when we go to our graph, we start at 3. It's just less than 3, right? Or 3 is less than x. It's not less than or equal to. So I'm using an open circle at 3 because the 3 is not included. And then x are going to be the numbers bigger than 3, which means we're moving off to the right side. But there's no number on the right side where we stop. So it's just going to keep on going forever. And the way I show that on the graph is just drawing that arrow darker. It means we're starting at 3. Right, not including 3, so like 3.00000001, and then any number bigger than 3 going forever off to the right. Right, and then the way that we can show that with the interval notation is just by looking at the graph here. Our left-hand number is 3. Right, so I start with 3. 3 is not included, right? It's an open circle. It's just the less than symbol here. So if it's not included, it gets the parenthesis. But then what number can I use for the right number, right? My inequality doesn't have a number on the right. My graph here goes to the right forever. Well, if you go along the number line to the right forever, you're going towards infinity. So that's what we use as our right-hand side of our interval. Right, we're starting at 3 and we're going all the way off to the right, all the way towards infinity. Right, now notice with infinity, I use the curved parentheses here, not the square bracket. Remember, the square bracket means that that number would be included in the interval. Since infinity is not an actual number, it's just the concept of something that keeps on going forever, you can never actually reach infinity. Right? You can never get to a number and say, okay, that's infinity, that's the end of my interval here, because it just keeps on going beyond that. No matter what huge number you find, there's going to be numbers that are bigger. Right? So the infinity always is going to get the curved parenthesis. Right, the next one here, we have a graph that starts at -4, with the -4 filled in, right? -4 is included, and it goes off to the right, and the arrow just keeps on pointing off forever. So it's going to be the same kind of thing. The difference between this one and that, the last one, is that on this one, that -4 is included, which means I start my interval notation with the bracket -4, and then since it's going off to the right forever, my second side is infinity, and like I was just saying, infinity always gets the parentheses. All right, and then for my inequality notation, it would be -4 is less than x, or x is greater than -4. Either one of those is correct. The reason we usually use this less than is because that's how all these other inequalities are set up. So we just kind of, to stay consistent, instead of saying x is greater than -4, we usually say -4 is less than x. All right, so that's that one. The next one, we have another interval notation here that involves infinity, but now it's -infinity, comma 1. All right, so if we think about this, I'm going to do this one by doing the number line first. All right, so -infinity is to the left side of the number line. If you go forever to the left of the number line, you're going to get towards -infinity. And then it's going to the right, stopping at +1, and 1 has the parentheses, which means 1 is not included. All right, so I put an open circle at 1 and draw my thicker line up to there, and this time the arrow points to the left forever because it's going all the way down towards -infinity. Right, so the way that you would show this one is an inequality, right? X is going to be all the numbers that are less than 1. Right, this one, there's no number to put on the left side because it's going all the way down towards -infinity, which is not a real number. So there's no number to put on the left side, but you do have a right side boundary, which is +1. Right, and since the 1 has the parentheses, it's not included, so it's just x is less than 1. Right, the next one we have is similar. X is less than or equal to -5. So since it can be equal to -5 this time, so on my graph I do a filled in circle for -5. Less than means we're pointing off to the left. All right, so x is less than -5. We're going, starting at -5 and then going to the left forever. So for our interval notation, we don't have a number on the left side, so we use -infinity, comma -5, and since -5 is included, it gets the square bracket. All right, and then the last one we have here, we've got the number line basically going in both directions forever. Right, which means our interval is going from the left, -infinity, all the way to the right, +infinity. And remember, the infinities always get the curved parentheses, so they both get curved parentheses. And what this represents is really no inequality here. This represents all real numbers, which sometimes we use the symbol of like an R with like a double line here to represent all real numbers. Right, so x in that case could represent all real numbers. So that's an introduction to inequality and interval notation.